Hello and welcome to another video in this series as we learn the basics of Lean for writing simple maths proofs. Today is the last in a mini-series, I guess, of 4 videos, the fourth of 4, where we have been looking at conjunction and disjunctions in the hypotheses and proofs. So with video number 7 and then 8, 9 was the last one, and now it's the 10th one. In the 7th one we looked at proof by cases, which is essentially or disjunctive hypotheses. Then we looked at conjunctive and hypotheses, and we saw that a conjunction is essentially the same as having multiple hypotheses that are all true. Last time we looked at the goal, not the hypothesis, and it's quite interesting because we had a disjunctive goal, so at least one of the substatements in a disjunctive goal had to be true, and we could either have some choice or no choice about which one to prove. And today we're going to be looking at conjunctive and goals, which is less interesting compared to last time, so the video won't be very long, but we just need to know how to handle those cases. So let's dive in. So the task that we've set is again really simple. As you know, we don't choose maths problems that are overly difficult because we don't want to get distracted. The idea is to learn about Lean and writing proofs in Lean rather than getting bogged down with, algebra kind of horror. So we've got an integer which is x and it's -1. That's what we're given. That's the hypothesis. And our proof objective is a conjunction. It's an and. So x squared is 1 and x cubed is 3, and we have to prove that's true. In order to prove that's true, we have to prove that every part of it is true. Remember, with conjunctions, let's draw a picture. So with a proof goal, which is a disjunction, we could either prove that or that, or both, but that's just a waste of time. But with a conjunctive goal, that should have been a Q there, we have to prove that and that. They both have to be true, because if one is false, then the conjunction is false. So if I've got a conjunction P and Q and R and S, if any one of these is false, then the whole thing is false. So they all have to be true for the whole thing to be true. So for our task, we have to prove all of it, both parts. That means we have 2 goals or 2 sub-goals. We have to prove this is true and this is true. Not a difficult concept, but we're just getting our thinking clarified before we approach any code. So just a reminder, P and Q means both P and Q must be true. So we have to prove both x squared is 1 and x cubed is -1. So we're going to write out a slightly laborious proof, and we do these because the structure that we write down is halfway towards writing a Lean proof, so we're trying to get our brains to think in that way. So we start with a given fact and the proof objective, and then we have 2 things to prove. We have to prove this and this. So it's not sufficient to prove one of them, you have to prove both. So that's what the next part of the proof does. It proves x squared is 1, which is this one, and then it proves x cubed is -1, which is this one. And those 2 things are proven, so we then can say, actually this is wrong, I need to correct this, but both of those things being true means that the conjunction is true. So ignore this, actually this is wrong, I'll have to correct that in the slides and re-upload them. So let's look at the Lean code for this, and you can see straight away that it's already got a different structure. There's something else going on here, so we'll talk about that. Let's start with what's familiar. We've got x being declared as an integer. We've done that lots of times. We've got a hypothesis, h, that x is -1. We've done that lots of times. We've got a proof objective, which is a conjunction, a logical AND. X squared is 1 and x cubed is minus 1. And then we know from doing the maths proof that we need to prove both of those things. So somewhere in here we've got to prove both. And you can visually see there's two calc sections, each one proving each of these things. So the first one is proving x squared is 1 using the standard approach, the substitution, using the rewrite tactic, and then by arithmetic using num norm. We've done that lots of times. So this itself is familiar. And then the same again, x cubed is minus 1. This bit is familiar, the calc section, but there's two calc sections. So how do we go from here to writing two calc sections? Well, we use this thing called a constructor instruction, and what that does, it takes this proof goal, the current goal, that's a conjunction, and splits it into two separate goals that we have to prove one after another. When we look at the info view, we'll see that. You might not have seen these before, these dots. That's not something on your screen. Those are actual focusing dots. And what they do is two things. One is that they show visually that there's a sub-proof here and a sub-proof here to support the entire proof. So it shows some kind of substructure. But also in the info view, if you click inside the scope of one of these dots, the info view limits what it shows to what's relevant to that subproof. So there's just cleans up the information to what's relevant, and we'll see that in a minute. So they're good. It's good practice. It's good style to use those. So they're useful when you have more than one goal to prove, and we'll see more of those as we kind of learn more about Lean. So let's actually have a look at some live code. So you can download this from GitHub if you want, and you can use Visual Studio Code, or if you don't want to install anything, you can use the online Lean environment linked from the blog, and it's kind of run by the Lean team, and you can just code completely in the web. And let's have a look then. So we've got x as an integer hypothesis, x is minus 1. We've got the conjunctive proof objective, and it's useful to see by clicking at the end of this line, or the beginning before constructor, so before it's run, you can see the state of play. So Lean thinks that x is an integer, that's correct. It knows about a hypothesis that x is minus 1, that's correct. And it knows, or it thinks correctly, that the proof objective is this conjunction, x squared is 1 and x cubed is minus 1. After the constructor instruction has been run, then you can see things have changed on the right hand side here on the info view. Now we've got two goals, and in fact it tells us two goals. Both of those goals have similar context. Both of those goals have x as an integer. They both have the same hypothesis, h, x is minus 1. But the actual proof objectives are now different. Here it's x squared is 1, and here is x cubed is minus 1. So it's these two parts, one after another. So we now have two goals, and we just have to do them one after another. That was a short video because a conjunctive proof objective is not that interesting. You just have to prove everything in it one after another. So the main new thing that we learned today is about the constructor instruction that splits a conjunctive goal into separate pieces. So the easy exercise follows a similar pattern to last time actually, where we've got a longer statement. So we got integer x is minus 1, and now we have to prove this conjunction. So in the last video we had to prove a disjunction, and we just had to pick one of these pieces. Now we have to prove all of these are true because it's a conjunction. So you can imagine using the constructor, and this will turn into three goals, not two but three. There's no left and right here because we're not picking one, we are having to prove every part. Actually, there is something interesting here. The constructor splits it into the head and the tail, so you will have to use constructor again to pick off the bits that you want to prove. Let me draw a picture because that might be unfamiliar. So if you've got a conjunctive statement P and Q and R and S, if we issue constructor, then that splits into two goals, P and then Q and R and S. So it doesn't actually split it into 4, it splits it into 2. And then if we issue constructor again, then we get P and then Q and then R and S. And constructor again, and then we get P, Q, R and S. So it's working down the list, as it were. Both the left and the constructor have the same idea of a head and tail. So it picks off the head, and the tail is whatever the rest is. So that's the idea. That's how they work. So have a go at that. This is good practice, so it's not particularly challenging mathematically, but it's practicing using these new instructions that we're seeing in Lean. And remember to use the focusing dots, because that's good practice. Any problems, do comment and we'll have a look and have a conversation about it. And we'll see you next time. Bye.